Okay, so we're going to get into the measuring a resonant frequency on a coil, and this is going to be handy for anybody who knows how to do that in here, to measure a resonant frequency of a coil. So just a few. Who thinks it would be useful in your own experiments if you even do experiments? Good hand, yeah. So it's applicable for all kinds of things. I was using it to measure resonant frequency of ignition coils and different ones to see which ones are going to be more suitable for different kinds of experiments. And you can use this exact method for all of that. So on this, the basic components, and I'm going to be walking in front of this screen here in a second, Phil, for that one. Let me see the... Let's see that. Let's see, signal generator. Voltmeter. Okay, so what you'll need, and there's more sophisticated ways to do this. There's like a vector network analyzer, which I guess is kind of the top of the line way to do it, which is a device that you can hook onto a coil, and the laptop will just run the software with this little piece of hardware, and it will kick out and show you all the resonant frequencies and all these different points and everything of what happens in a coil. I have like a little $600 one. That's pretty good quality. I don't fully know how to use it yet. It still has to be calibrated and all that. Somebody next year from the UK will be doing a pretty extensive talk on vector network analyzers and how to use them for these kind of purposes. It makes it simple. It gives a lot more data than what we're going to see here. But at bare minimum, for a very simple way to do this, you need a current transformer. So all this basically is like a ferrite ring. Okay, so this is basically a ferrite ring core with two wires, which are basically wound in parallel. That's black shrink tube, just to identify one wire from the other. Okay, so at around 722 kilocycles, the meter is kind of peaked. And as soon as I go backwards, 722, 721, 720, right when I hit about 716, it's starting to fall back towards the zero. Not all the way, just a little bit. So you're looking for the dip. And I'm at 715, it dipped a little bit more. 714, it dipped a little more. 713, it dipped even more. I went to 712 and then it went up, which means I passed that resonant point. Are there any other situations, Eric, where this type of measurement method would be used on a regular coil, or only when you have some type of spark gap arrangement, or
any parallel resonant circuit?
Any parallel resonant circuit? And the other one you would consider a series resonant circuit? So the first one is series resonant circuit, and this is a parallel resonant circuit, and those are the two different ways you measure it depending on which one you have.
The connection you have, I don't think that's right. Can you put the meter on one lead and the signal generator on the other and see what it does?
Keep them on the same color?
Yeah.
Yeah, the way, and I actually couldn't get that way to work,
okay.
But we can try it real quick. And 724, so that's, 11 kilohertz difference. Ideally, they match perfect.
They're unbalanced because you got that frame there.
Yeah, all this and everything, so you can see that you really do need to be out kind of in an open spot. So anyway, we'll have this set up on one of the machines back there if anybody wants to kind of go through this and, play with it and see how it works. But it's very, very handy. Add these little tiny coils, for like these little Tesla lighters and stuff like that, that puts out like a little plasma flame. Those kind of things, you can get them on Amazon and stuff for different experiments, little high voltage kind of things. It works perfect on those. Ignition coils, so there's probably 6 or 7 coils that I've measured looking for, how do I make a little small scale, MWO, small scale, using the exact same method. So, I don't know, does anybody have any questions? Just showing I got 13 slides. I don't know what else is on there.
Could you recap how you changed the
Blank slides.
last wiring?
Sorry, what was that?
Can you recap how you changed the wiring on that last meeting?
Okay, so what this is the voltmeter. 2 leads from the voltmeter are connected directly here and here to the cap bank. And then the signal generator is connected to one winding on the coil.
What you can do is you can move them closer or farther apart to compensate for whether
Yeah.
there's a person in there or not.
Yeah, I can't remember how many kilohertz it drags it down when you're sitting in between. And typically our benchmark kind of measurements and stuff, we have these at 33 inches, which we didn't measure right now. Center of the ring to the center of the ring, 33 inches. And that's kind of our baseline measurement. And then, so if you're inside and you drag it down a little bit, it's still going to be within the frequency that Lakhovsky was operating at. He had 3 variations, like,
Actually, no, you can do that if you set the thing up somewhere else. That'd be a good experiment for people. You know, measure the frequency with
Sure.
somebody sitting in and measure
Yeah.
with somebody sitting out.
yeah, so we'll set it up back there and we can do that. Any other questions, or go ahead?
There's,
When you're measuring the frequencies, you're measuring the balance between the MWO
It's the,
extra coil.
yeah, okay, so measuring the resonant frequency is basically the frequency that it's operating at where everything is kind of synchronized, where it can turn off and turn on, accounting for all, you know, the resistance of the wire, how many windings you have, the inductance, and if you take basically every single parameter and you figure it out, well, with all of those things put together, what frequency is it going to operate at to be the most effective, accounting for all those? This shows you it without having to know all those things. Because you could actually calculate the windings and, you know, do all this on paper to know what the frequency is supposed to be. It's a little bit kind of complicated. So that why, you know, so with the voltmeter anybody can do it and you don't have to really know what all those things are. Did you have a comment on it, Eric, or?
there's no way you can calculate this stuff.
Yeah, it gets pretty crazy. So, any other questions, or? Okay, well that's it. I hope that was at least a little bit helpful, and we'll have it set up for people to play with, and that's the end of the presentation.